Wait, we do not have enough time for me to discuss the woes of balance in your day-to-day lives, right? Balancing homework and schoolwork and from. Why are you covering your face? Are you okay?
No, just.
Okay. Okay. This should be more thoughtful. Likewise, in science, we must balance equations. In this case, we are going to balance chemical equations, which means we have some things mixing together to make a new thing. Okay? Now, the amount you start with has to be the amount you end with because of the conservation of mass. Okay? So whatever you begin with, you have to end with, and you kind of want things to work out nicely. So today we are going to write chemical equations.
You're adding them too?
Yes.
Yeah.
So, so that's section 8. Watch out. That's like the worst result that could possibly happen. So like falls in a little crack rock. Well, hitting reset, yeah. I could hit others too. No. All right, so writing. I know, isn't it sure cool? Round 2. Woo! Round 3. There we go.
Are you good at golf?
Absolutely not. I hate golf. I'm horrible at it. All right, so we have 2 parts of an equation. We have the reactants, and they make the, isn't it, products. So something or some things, some compounds, some elements are going to react to form the products of our chemical reaction. Easy enough, we'll use the little arrow to denote that something has happened, reaction has happened, and now we are resulting in the products. So, here we go. So let's say we mix this device. Now while we're doing this, we might as well do some naming practice for Wednesday's exam. So, what is this guy?
Oh, calcium hydroxide carbonox.
Okay, so let's start. This will be a good review for us all. CO3 is
Carbon.
CO3. C is what? Carbon. It has an oxygen attached to it, so it's either carbon 8 or carbon 8. Which one is it?
8.
Carbon 8. Carbon 8. And so this is calcium hydrogen carbonate. And if it was just HCO3, what would it be? Remember when there's a hydrogen attached, we have when there's a hydrogen attached, it becomes an acid. So we have carbon 8. When we add the hydrogen, it becomes So for the acids, right, you take off 8 and replace it with IC and then acid. For the ites, it would be carbonous acid, OUS. OUS, not just O. You said, oh, no, OUS. MICKEYMOUS. Okay, so that one's tricky. What's OH minus? Oh dear, you must study. You must study your H. OH minus. Come on, guys.
Oh.
Hydroxide. That's correct. So Ca is calcium hydroxide. Okay.
Wait, Miss Glenn, is it an acid because it has the hydrogen in it though? Hydroxide
No.
acid.
So remember our discussion, if it has an H attached to it, it's usually an acid. If it has an OH, it's a
Base.
so things are either more acidic
Wait, the other one was a base.
or more basic. And then what's right in the middle? Water, because it's got an H and an OH.
Wait, Miss Glenn, the other one had oxygen in it.
Did it have an OH molecule on it though?
That doesn't-
No, it has a hydrogen and it has some oxygen somewhere else.
So I just
So carbonate is a thing, right? You have your C, O, O, O. So 1, 2, 3, 4. So we start connecting things like crazy, right? What is it? CO3 2 minus? You sure?
Yes.
Okay, so we'll throw a couple extra electrons in here. We got there, there, there. Yes. Okay. So that's carbonate. Now the hydrogen attaches to that. So you have like something gross going on there. Okay. Then calcium bonds to that. So it's not an OH molecule that's attached. The oxygens are separate. Oh. So it would have to be like C O H.
Oh, that makes sense.
So the OHs, if it is a base, they're like attached to the OH. As opposed to oxygens, because there's always going to be oxygen and hydrogen around things. Yep. That's fine. Kind of annoying though. Yep. Good luck. All right. So this is water, which is
Not a base or acid.
dihydrogen monoxide. This is. Okay, I already named this one over there. We already said what this was. What's this?
Oh,
Come on, guys. What's CO3? 2 minus.
carbonate.
Carbonate. So this is calcium carbonate. Homework. Review flashcards. For 15 minutes. I mean, I'm not going to know if you did it or not, so you can do however many minutes you want. I like 0. Who's in charge of putting up posters for student council? Okay, so please review your flashcards. You must know these. I know it's horrible. I know it takes time. This is the way.
This is the way.
Sorry. What's up? Carbonate. Carbonate. Okay. Now, let's go back to our actual study today. We are trying to balance this chemical reaction. We want to know how much of our reactants are required to make these products. Why? Because you don't just kind of throw stuff together and hope for the reacts. I mean, you do, but if you want to do real chemistry and real science, you have to know how much of this and how much of this are required to make the amount of that you want. Okay? So if I need twice as much of this as I need that, I have to know that ahead of time in order to have a successful reaction. Otherwise, I'm going to have a bunch of other leftover stuff that I don't want at the end. Okay? If my goal is to get calcium carbonate out of this, And I have to put in the correct amounts of each of these compounds in order for this thing to work. Okay? So we have to balance this. Now, let's start with this side. What I'm going to do is I'm going to count how many of each. Should I write this step? Won't write it. It's like the student-teacher contract of raising your hand, right? Micah, what's your question? Your hand was up here. Therefore, you have a question. I have a question? Just tell me right here. Okay, so step one, we're going to write the number of each atom on the product and reactant side. P stands for product, R stands for reactant. Give me a moment to write. Write faster. Write faster. Okay. Got this. So, what's up? P stands for product, R stands for reactant. Okay, so let's do that now. We have calcium and calcium. How many of those do we have? 2. One here and one here. How many do I have on the, so this is going to be my reactant side. This is my product side. How many do I have on my product side? Okay, is it balanced? No. Okay, let's continue. How many hydrogens do I have on this side? Nope. 4. There are 4. Why? Because this one, there's 2 of, and this one, there's 2 of. So there are 4 here. How many hydrogens are on this side? 2. Next, let's go to carbon. Can I stop whistling? I cannot whistle, therefore you are not permitted. I know. How many carbons? Come on, guys.
3.
2. C2. This side, how many? 1. Okay, how many oxygens? This little like underlining trick kind of helps you keep track.
3. 6.
No.
8. Is it 2?
Yes, 8.
There are 8 on this side.
8.
Why? 3 times 2 is 6, plus 2 is 8. Over here, I have 1 plus 3, which is 4. Is this balanced? No. So what I'm going to do now is I'm going to adjust the scales, right? It's like when we talk about like planning your life out, right? And it's like if you have 50 hours of homework because you took Calc 2, and you're like, homework. And then you have to balance that with something else that's going to lose time in order to make up for that, right? Hopefully not sleep, but potentially, right? Or choose to get a job. You're like, I'm working hard, right? Making those like little ice cream cones, and you're the guy who gets like the my ice cream cone. And your coworkers are like, they just keep going, and the ice cream's like this big, and it falls over people's back. Okay. It's always broken. It's always being clean.
I work there. It's
No,
not
because they clean it and they just don't want to.
Okay.
They don't want to.
So,
Oh wait, I have a question.
well, I went to Chick-fil-A and they wouldn't give me a large
We don't have
milkshake.
cones? Oh, we don't have large cups.
I know. Anyways, so now it is our job to balance.
Oh wait.
Yes.
So why?
I heard you the first 4. I see the hand. The sacred student-teacher contract is maintained. Every question, even extra questions like that hand raise, have been answered. And that one, and that thinking of those, and that thinking of.
Are you blind?
What?
I have my hand above my.
No. Grace's hand was above the shoulder. And
I'm not doing it.
these two. Okay, question.
So why is the in the reactant side? Why isn't it 4 oxygens?
one here, and one here.
Oh, so it didn't do that.
Right. Those are in the parentheses. So the two distribute.
Okay.
Good question. Now the reason it's written that way instead of H2C2O6 is because that is a different compound. Okay? The HCO3 is a compound, and you have two of them attached. That would be something completely different. I don't know.
Is it because
It's like a hydrocarbon thing. I
he's
don't know.
factoring there?
We'll get to that in chapter 19. We're on chapter 8, if we get there. Organic chemistry. We'll bring in Miss Holmquist to teach that one. Okay, now, how do I balance this? Well, I am going to put numbers in front of these to determine how many of each molecule I want to have. Now, there's an easy way to do it and a difficult way to do this. Okay. Let's try it the difficult way. Let's just eyeball. So, I have one calcium here, and I have two here, and I have one here. So, we could try multiplying this term by 2. So, here's what you're going to have to do. Be careful to do this. When you start multiplying, you want to update your numbers. So what I want you to do, like on a test, you would write these out, and then as you multiply things and try and figure it out, you're going to cross these out. So I think this one needs a 2 in front of it. Because I want 2 calcium instead of 1. So instead of erasing, which would be horrible, I want you to cross it out and then change it. Okay? So, is that the only thing that changes? No. I've also changed the number of carbon I have. So now I have, how many?
2 carbon.
2. I've also changed the number of oxygen I have. How many?
They're, no, actually.
To 6.
Don't.
8.
I thought we were timesing it though.
It's not 4, 6, or 8.
What?
How many
Times four,
oxygens
guys.
do I have now on this side
Oh, it's
of the
7
equation?
now. It's 7, right? 4.
Oh.
Let's
Right.
count. Oh man, it's like Dora the Explorer. Are you ready? You ready? 1, 2, 3, 4, 5, 6, 7. 1. Now I have 2 of these. 1 plus 6 is 7. I would never make a good children's television host. It's fine. Instead, I host you guys every day. Question. It's recording right now. It's watching. Hi, Mivo. Hi, Marisa. That's fine. All right, guys, let's welcome our online audience today. Hey, guys. So today we're gonna just record it. I'm too lazy to do it live. Sure. But then I post it like 2 minutes later, so close enough. Okay, is this balanced?
No.
Nope. Now what's wrong? Calcium is good. Hydrogen, wrong. Carbon, good. Oxygen, wrong. So now I want to try again. What else could I change? Because I've got some of them right. So I don't want to I don't want to change that necessarily. I could change any of these other terms. If I change these, then it's going to mess up my calciums and I'm back to square one. So what's left? The water. Here I have 4 hydrogen. Here I have 2. Maybe if I multiply by 2, it will change. So let's see. Now I have how many hydrogen over here?
4 hydrogen.
Okay, I need more than just Ryan participating. That's everybody. 4. How many oxygens?
7. Wait.
We need one more oxygen.
8.
Wait.
2 times 1 is 2. 2 times 3 is 6. 2 plus 6 is 8.
So how did we get that extra one?
So here, if I were to write out everything I have 2 hydrogens and an oxygen. I have 2 hydrogens and an oxygen. Okay, how many oxygens do I have? 2. How many hydrogens do I have? 4. Now if I write this out, Ca, carbon, 3 oxygens. But I have 2 of these. How many oxygens do I have? Here we go. This is how you do it.
6.
1, 2, 3, 4, 5, 6, 7, 8. 8 oxygens. How many carbons? 1, 2. How many hydrogens? 1, 2, 3, 4. How many calciums? 1, 2. Is it balanced? This was wrong. It is now correct. This was wrong. Wait, that was right. This was wrong. Now it's correct. So this is our balanced chemical equation. Okay. Official instructions. Rule 1. I'm going to write the formulas for products and reactants. So they are most likely going to give you these based on the written out names of each compound. You will have to write the formulas. That's why we learn naming first. So as an example, which I will do in the purple, we have we're given that as our problem. We're supposed to balance this chemical reaction. First step is to write the formulas for each of the products and reactants. What's nitrogen monoxide? Come on, guys. Nitrogen monoxide.
NO.
Nitrogen is N. Oxygen is O. There's one of these and one of these.
No, that's not
NO2.
I'm adding oxygen. What's the chemical formula for oxygen? Think about it, though. This is a trick. Wait, hold on.
O2.
Stop. This is a trick question. So think carefully. I don't want the oxygen ion. I do want oxygen. How does oxygen come in its natural state? Take like 5 seconds. Let everyone process. The answer is everybody. Everybody, come on.
Oh.
Oxygen, diatomic. You must put O2. So if you're adding elemental oxygen, bromine, chlorine, iodine, what are the other ones? How my hands get so dark? I'm gonna erase them with my hand. Sulfur and usually hydrogen. You're gonna have 2 of them. Okay? So if they give you the name, know that it's diatomic. That's why you memorize that list like a month ago. Okay? Okay, this makes nitrogen dioxide. 2 of those, 1 of them, NO2. Is this balanced? No. Step 2. Check to see if the equation is balanced, or write number. Okay. How many of each atom do I have? Andrew, start us off. So, and just like we did over there, on the reactant side we have.
Oh, like that. Oh, okay. For nitrogen, right?
How many
2.
on this side?
Oh, just now like 1.
Okay, next, Micah.
Oh.
Okay, good. Next step. Is it balanced? No, we have more work to do. Let's get down to business to defeat the Huns. Okay, number 3, we are going to adjust coefficients. So that's the numbers in front of these. So each time we do that, we're going to cross out. Okay, nitrogen matches, oxygen does not. What are we thinking? Yeah.
Add to the before the N.
Which one?
NO2, nitrogen dioxide.
But why? The ends are already balanced.
Yeah, so you have to add because you must add to mark up.
Okay. So you're kind of thinking through resources. Your answer is correct. But let's talk this through. Even though something matches up, if the other ones don't, then you don't have a balanced chemical equation. So who cares if they match up? You still have work to do. So you have to think now. Each time I multiply this by something, I'm adding 1 nitrogen and 1 oxygen. I see your hand. I'm going to keep talking now. I will get to it in a moment. Each time you change this one, you're adding 1 nitrogen, 1 oxygen. Each time you change this one, you get 2 oxygens, no change in nitrogens. Here, you get 1 oxygen and 2 oxygen, 1 nitrogen, 2 oxygen. So, let me pose this question to you. Which of the 2 numbers must be the same? Think in your mind. Which of the 2 numbers must be the same in order to balance? Think it out. I see your hand. I'm not going to call on you right now. It's okay. We'll get there. There'll be a time for questions and answers. Think about it. Thinking happens in here. You must think. Which 2 of these 3 numbers must be the same? Maybe all 3 are the same, but at least 2 of them have to be the same. And I'll need an explanation why, and I'm calling on a random volunteer. Esteban. Well, I've already exhausted the front row. I usually go by row. Which 2 must be the same? Take a guess, and why?
O2.
And 2 of them must be the same. Okay, your answer is rejected. I will come back. Who is that? Which 2 must be the same? Ooh, because they're reactants. I disagree. But a good guess. Any other guesses, Michael?